Space, the final frontier. Our universe is filled with cosmic wonders that captivate the imagination, but no object is more mysterious, more terrifying, and more awe-inspiring than the black hole. These cosmic giants are born from the deaths of stars and possess gravitational forces so strong that not even light can escape them. Today, we're diving into one of the greatest cosmic mysteries, how stars become black holes, and what secrets these enigmatic objects hide. Could black holes hold the key to understanding the universe or even other dimensions? Let's start at the beginning. Stars are the cosmic engines of the universe, born from massive clouds of gas and dust called nebulas. Gravity pulls these particles together, and as they collapse, they heat up, igniting nuclear fusion at their core. For billions of years, a star burns brightly, fusing hydrogen into helium, creating the light we see in the night sky. But like all things, stars too have an expiration date. At first glance, stars seem eternal, but their fate is sealed by the very forces that keep them alive. When the fuel runs out, the star faces a dramatic end, one that could ultimately lead to the birth of a black hole. Stars exist in a delicate balance between the inward pull of gravity and the outward pressure of fusion. As long as fusion is happening, the star remains stable. But what happens when the hydrogen at its core is exhausted? Gravity wins. The core begins to collapse under its own weight, and in massive stars, this collapse can trigger a chain reaction, leading to a supernova. Here's where things get intense. If a star is massive enough, at least 20 times the size of our Sun, its core can collapse into something unimaginable, a singularity, a point of infinite density, and thus a black hole is born. When the core of a massive star collapses, it marks the beginning of one of the most dramatic events in the cosmos. This process is triggered when the star has exhausted its nuclear fuel, causing the core to lose its outward pressure. Gravity takes over, pulling the core inward with immense force. The energy released during this collapse is so intense that it causes a supernova, an explosion of such magnitude that it can briefly outshine an entire galaxy. This explosion is not just a simple burst of light, it is a cataclysmic event that releases more energy in a few seconds than our Sun will emit in its entire lifetime. Imagine a single star outshining billions of stars in a galaxy. For a brief period, the supernova becomes the most luminous object in the universe, visible across vast cosmic distances. This incredible brightness is due to the release of a tremendous amount of energy, which illuminates the surrounding space. The explosion scatters the outer layers of the star into space, creating nebulae, vast clouds of gas and dust that can span light years. These nebulae are the birthplaces of new stars and planets, recycling the elements forged in the heart of the original star. The remnants of the explosion spread out, enriching the interstellar medium with heavy elements. Meanwhile, the core, if heavy enough, continues collapsing under its own gravity, eventually forming a black hole. This process is so extreme that it warps the very fabric of space and time. The core's collapse is halted only by the formation of a singularity, a point of infinite density. Supernovae are among the most powerful events in the universe, releasing more energy in a few moments than our Sun will in its entire 10 billion-year lifespan. They are not only spectacular to observe, but also crucial for the evolution of galaxies. But what they leave behind is even more mysterious. The aftermath of a supernova can be a neutron star or a black hole, depending on the mass of the original star. These remnants are the key to understanding the life cycle of stars and the dynamics of our universe. The remnant core becomes a black hole, an object with such intense gravity that not even light can escape. This gravitational pull is so strong that it bends light and warps space-time around it, creating what is known as an event horizon, an object with such intense gravity that not even light can escape. The event horizon is the point of no return. Once something crosses it, it is lost to the black hole forever. The black hole continues to grow as it absorbs more matter and energy from its surroundings. But what really happens inside? The interior of a black hole remains one of the greatest mysteries in astrophysics. Theories suggest that the laws of physics as we know them break down inside a black hole. leading to phenomena that we can barely comprehend. Could black holes be gateways to other dimensions? Some scientists speculate that black holes might connect different parts of the universe or even different universes altogether. These ideas, while still theoretical, open up fascinating possibilities for the nature of reality. Or are they cosmic tombs from which nothing returns? The true nature of black holes remains elusive, but they continue to captivate our imagination and drive scientific inquiry. As we study these enigmatic objects, we inch closer to understanding the fundamental workings of the universe. What lies beyond the event horizon? This question has puzzled scientists and astronomers for decades, if not centuries. The event horizon is a boundary in space-time beyond which events cannot affect an outside observer. It is the ultimate point of no return. The event horizon is the point of no return. Imagine a spaceship approaching this boundary. As it gets closer, the gravitational pull becomes so strong that not even light can escape. This is why black holes appear black. They trap everything, including light, within their grasp. Once anything crosses it, matter, light, information, it's gone forever. Or is it? This has been a topic of intense debate among physicists. Some argue that information is lost forever, while others believe it might be preserved in some form. According to Einstein's theory of general relativity, once you cross the event horizon, you fall towards the singularity at the center of the black hole, where gravity is infinitely strong. The singularity is a point where the curvature of space-time becomes infinite and the laws of physics as we know them cease to function. But recent quantum theories suggest that something stranger might be going on. Quantum mechanics introduces a new layer of complexity to our understanding of black holes. It suggests that the information swallowed by a black hole might not be lost, but could be encoded on its surface. Could the event horizon be a holographic boundary that encodes information about everything inside the black hole? This idea, known as the holographic principle, proposes that all the information contained in a volume of space can be represented as a theory on the boundary of that space. Scientists are still grappling with this paradox. The reconciliation of general relativity and quantum mechanics remains one of the biggest challenges in modern physics. Theories like the holographic principle offer tantalizing possibilities, but are far from being proven. Is the event horizon a one-way street to oblivion, or does it hold secrets about the fabric of space and time itself? The event horizon could be more than just a boundary. It might be a gateway to understanding the very nature of reality. Some theorists even propose that black holes could be wormholes, tunnels connecting different regions of the universe, or perhaps different universes altogether. If this is true, then black holes could be the key to interstellar travel, offering shortcuts through space-time. The mysteries of the event horizon continue to captivate our imagination, pushing the boundaries of our knowledge and challenging our understanding of the universe. Time behaves very differently near a black hole. Due to their immense gravitational pull, time slows down as you approach the event horizon, an effect known as time dilation. This bizarre consequence of Einstein's theory means that theoretically a journey to a black hole could allow you to experience time travel of sorts, but would you survive long enough to see the future unfold? Imagine approaching a black hole. As you get closer, time for you slows down relative to someone observing from a distance. Could black holes be nature's ultimate time machines, allowing glimpses of the far future or distant past? But beware, get too close and you'll never escape. In 2015, humanity detected gravitational waves for the first time, ripples in space-time caused by the collision of two black holes. This monumental discovery confirmed yet another prediction of Einstein's general relativity and opened a new window for observing the universe. When two black holes collide, they send shockwaves through the very fabric of reality itself. Gravitational waves. These waves allow us to listen to the universe in a whole new way. What else could we discover by listening to these cosmic echoes? Could they be telling us something even stranger than we can imagine? Supermassive black holes, the monsters at the heart of galaxies. These cosmic giants are some of the most fascinating and enigmatic objects in the universe. Their immense gravitational pull is so strong that not even light can escape, making them invisible to the naked eye. Yet, their presence can be inferred by the way they influence their surroundings. At the center of most galaxies, including our own Milky Way, lies a supermassive black hole. These colossal entities are millions or even billions of times more massive than our Sun. They are the gravitational anchors of their galaxies, holding everything together in a delicate cosmic dance. These titanic objects, millions or even billions of times the mass of the Sun, remain one of the greatest mysteries in astrophysics. Scientists are still trying to understand how they formed and evolved over time. Did they start as smaller black holes that gradually grew by consuming stars and gas? Or were they born massive from the very beginning? How did they get so massive, and why are they found at the center of galaxies? These questions have puzzled astronomers for decades. Some theories suggest that supermassive black holes formed from the collapse of giant gas clouds in the early universe, while others propose that they grew by merging with other black holes and absorbing vast amounts of matter. Supermassive black holes are not just cosmic anomalies. They may be essential to the formation and growth of galaxies. Their immense gravitational forces can shape the structure of galaxies, influencing the formation of stars and the distribution of matter. In fact, some scientists believe that without supermassive black holes, galaxies as we know them might not exist. But how did they become so enormous? The process of accretion, where a black hole pulls in gas and other material from its surroundings, plays a crucial role. As this material spirals into the black hole, it heats up and emits radiation, making the black hole visible to telescopes. Over billions of years, this steady diet of stars and gas can cause a black hole to grow to immense proportions. Were they born that way, or did they grow over billions of years feeding on stars and gas? The answer to this question could provide valuable insights into the history of our universe. By studying the behavior and characteristics of supermassive black holes, astronomers hope to uncover the secrets of their origins and evolution. The answers could reshape our understanding of the universe. Supermassive black holes are not just passive observers, they are dynamic and influential players in the cosmic drama. Their study could reveal new information about the nature of gravity, the behavior of matter under extreme conditions, and the ultimate fate of the universe itself. As we continue to explore the cosmos, these monstrous entities at the heart of galaxies will remain a focal point of scientific inquiry and fascination. Could black holes be dark matter? Dark matter. This mysterious substance makes up about 85% of the universe's mass, yet we can't see or detect it directly. Some scientists speculate that black holes, particularly primordial black holes from the early universe, could be the missing dark matter. What if black holes are the key to solving the dark matter puzzle? Could there be thousands or even millions of undetectable black holes scattered throughout the universe, shaping galaxies with their unseen gravitational pull? The implications are staggering, and we're only just beginning to scratch the surface. The information paradox. Does anything escape? Here's one of the biggest puzzles. What happens to the information that falls into a black hole? According to the laws of physics, information should never be destroyed, yet black holes seem to erase everything they consume. This paradox has baffled physicists for decades and has led to new theories that could reshape our understanding of reality. The information paradox is more than just a physics problem. It challenges the very nature of reality. Could it be that black holes store information on their surface like a cosmic hard drive? Or is the information lost forever, contradicting the fundamental principles of quantum mechanics? Stephen Hawking's groundbreaking theory introduced the concept of black hole evaporation. According to Hawking, black holes slowly lose mass through a process called Hawking radiation. Over an unimaginably long time, this radiation could cause black holes to shrink and eventually disappear. Imagine a universe where black holes don't last forever. Could these cosmic titans, which seem so eternal, actually fade away into nothingness? Hawking's theory suggests they can, raising new questions about the long-term fate of the universe. As stars die out and galaxies drift apart, black holes could be the last objects remaining in the universe. In this distant future, known as the heat death, the universe will be cold, dark, and empty, with only black holes slowly evaporating into the void. Is this the fate of the universe, a cosmos devoid of light, where only black holes linger in the cold darkness? The more we learn about black holes, the more we realize they might not just be the end of stars, they could be the end of everything. The idea that black holes could be wormholes, a shortcut through space and time, has captivated both scientists and science fiction fans. If black holes are wormholes, they might allow travel to distant regions of space or even other universes. But could such a journey ever be possible, or is it destined to remain science fiction? Could black holes be the ultimate cosmic gateways? Imagine traveling through a black hole and emerging in a completely different universe. It sounds like science fiction, but recent theories suggest it might not be as far-fetched as it seems. Black holes represent a collision of two of the most important theories in physics, general relativity and quantum mechanics. But you know, these two theories don't play nicely together. Understanding black holes could be the key to unlocking a theory of quantum gravity, which would unite the large-scale world of stars and galaxies with the tiny world of subatomic particles. At the heart of black hole research lies one of the biggest questions in physics. How can we reconcile general relativity with quantum mechanics? Could black holes provide the missing link, helping us unlock a deeper understanding of the universe? Some conspiracy theories suggest that black holes might be used by advanced extraterrestrial civilizations to harness vast amounts of energy, or as hiding places. While there's no evidence to support these claims, the idea of alien life interacting with black holes remains an intriguing possibility. Could black holes be the hiding places of advanced alien civilizations using the immense energy for purposes we can't even comprehend? While it's a theory on the fringes of science, the idea of intelligent life using black holes adds a whole new layer of mystery. The biggest mystery of all is what happens inside a black hole. Do the laws of physics break down completely at the singularity? Could there be unknown forces or dimensions within? We may never know, as no information can escape the event horizon. But one thing is certain, black holes are the most mysterious objects in the universe, and they will continue to fascinate us for generations to come. The singularity at the center of a black hole remains one of the greatest mysteries in the universe. We may never know what happens beyond the event horizon, but in our quest to understand, we are uncovering the deepest secrets of reality itself. Thank you for joining us on this journey through the cosmos. Black holes, mysterious, powerful, and endlessly fascinating, remain the ultimate frontier of our understanding of the universe. If you enjoyed this exploration, don't forget to like, subscribe, and hit the bell for more deep dives into the mysteries of space.